Good morning, everyone. My name is Asha, and I'm the Social Innovation Officer here at the Leicester Innovation Hub. Today's session is centered around what your business can do practically to achieve either net zero status or work towards your climate goals. Creating a local and regional and world economy that considers the effects of climate change is really important, and green innovation is key to that. It's particularly important at the moment in the lead up to COP26, which is the global climate conference taking place in November in Glasgow. And I hope this conversation and this morning's sessions will stimulate some questions and conversations that will be answered and discussed over the next few months. So the three sessions that we've got planned for today is firstly, process, product and service innovation within the green innovation field. Followed by marketing innovation, where we have a speaker, and finally at 11:15, organisational innovation and what practically you can do for your business or the businesses you work with to work towards your climate action goals. So could I please invite Carmine and Andy Abbott, please?
Good morning.
Morning.
And Simon.
Hello.
Good morning.
Good morning.
Okay. Thank you, Asha, and welcome to everyone to this session that incidentally will focus on one important aspect for sustainability and green growth, which is food, essentially. Food and agriculture. So we will be touching both these arguments today. And the interesting aspect, the underlying aspect is to focus on the innovation, which is in the processes, into the products, and how these can be done with an eye on the environment. So I would invite Andy to first introduce himself and let us know a little bit about what the university is doing and how the university is collaborating with businesses on a few ideas.
Okay, so thanks very much. Thanks for inviting me today. So what I'm going to do today is talk a little bit about ways of reducing waste. I'm going to give you some examples from activities that we've done in the food industry. My research group and the materials group at the University of Leicester focuses more widely on other aspects of waste, so things like recycling plastics, recycling technology metals, particularly looking at things like lithium-ion batteries is a big project of ours at the moment. But I'm going to focus here, because it is mostly with local companies, on the topic of food waste. And clearly one of the big issues that we face is that a lot of material is bought into a company, and clearly that's a cost to the company. But what you clearly don't want to do is to have another cost, which is to take the material that you brought in and deal with its disposal. So we've worked with many companies in the region, looking at food as a material, and looking at its properties and how to optimize the manufacture of that food waste, or that food material, so to minimize the waste that you have. And so we've also looked at the ways in which food deteriorates, and a lot of it deteriorates in the way its texture changes. So what you don't realize is that you are one of the most sensitive methods of analyzing textural changes. So your mouth and your fingers, particularly, you can stick your hand into a bread bag and you sort of feel it with it. Within a second, you know if that bread is fresh or if it's stale. And you're doing that by manipulating, using your fingers, working out the pressure required to feel if it feels squidgy or fresh. And you can actually do that very scientifically and quantify all of that. And so what we're doing is to look at food to understand how to make its quality better, but then also how to extend shelf life and how to minimize the amount of material that ends up being thrown away. So one process that we did, and I think Angie was talking about KTPs earlier on. So we carried out a KTP about a year and a half ago, it finished, with a company called Freshpack. And they are based up in Barnsley, and they make pretty much every single sandwich filler in the UK, and I think it's about 90% of all your egg mayonnaise for just about every end user is made in a factory in Barnsley. So I think they boil about 5 million eggs a week, and they've been doing it very successfully for about 25 years. And we rolled up there as a bunch of chemists, and we looked at their process, and we taught our grandmother how to boil eggs. So we were able to look at the entire process and reduce the waste from the process by 15%, which for the company equated to around about £1.5 million a year. And it involved very little other than just optimizing the processes that they had and looking at it anew with a non-food background to it, and looking at how to improve the quality. As part of that, we actually published for them what they call the Egg Cyclopedia, which was about a 100-page document on how to boil an egg and how to treat an egg, how to store it, etc. And as part of this, what we were able to do was also put a number of students into the project, and those were students capable of looking at not only the chemistry, but also we did a lot of data analysis looking at the sort of past history of how the sort of quality of their products had changed, and we were able to look at trends. So it's not only sort of chemistry that a university can put out these things, but it's also engineering, data processing as well. And what we were able to do is to sort of install state-of-the-art cameras to measure temperature, and temperature is very important both in the storage. So we changed a huge amounts in terms of their waste just by looking at how the egg was stored, how to cook it, how to cool it particularly, and we decreased significantly the amount of egg waste that was produced in the peeling process. We developed an overall test for how peelable the egg was, and in fact at the end of the process we were able to take off all of the eggshell from an egg in one whole piece. And we also helped them in terms of then how to get new products to market as part of a KTP as well. So they, as part of the KTP, also developed a soft-boiled egg product, which we also helped them to get to market. So it's a very good way of being able to help companies, even though they've been doing the business for years. And you can see that, you know, knowing nothing about eggs, we were able to save them a significant amount over a 2-year project. We've just started a new KTP with a company here in Leicester. It's about 2 miles from the Innovation Hub, called Food Attractions, and these are a fantastic company that we've just started working with, and they make these products called filled naans, and it's a bit like a Ginster's pasty, and they call it a naanster, so it's a naan bread. And the advantage of these is that they're much healthier, much lower fat than the sort of filled pasty, and they taste great. So one of the things we're trying to do with them is to extend shelf life and reduce waste from their process. And we're also putting into the company an innovation laboratory to help them to develop new products as part of their process. So we've got a chemist who's working with them, been there for about 3 months now, and they've seen huge advances in terms of their product development, even in a short amount of time. So KTPs really are a great way in which you can get innovation into your company. We also did a project working with Imperial, who many of you may know are based in Whetstone, and they make cookware and frying pans in particular. And what we were able to do through some consultancy work with them is to quantify their sort of non-stick properties of the pans, and we came up with a way of benchmarking their products. They wanted to claim how they were in the market, and we took, I think it's about sort of 60 of their competitor materials, and we developed a test that developed a way of measuring the non-stickability, non-stickware, and we were able to sort of quantify their products and benchmark them against their competitors. So we can do sort of fundamental research as well as sort of applied work. We've also looked at waste, and one of the biggest wastes, I think it's 1/3 of all bread produced worldwide is thrown away, and bread is just something which has got a large amount of starch. And we looked at a wide variety of starch and cellulose based materials, and we had a project looking at turning waste from the food industry, so it might be things like banana or orange peel, into boards or into material. And we worked with a local company in Market Harborough who make point of sale furniture. So they make the sort of counters that you'll see in shops, and they use a huge amount of MDF, medium density fiberboard, and this uses an adhesive called urea formaldehyde to stick sawdust together. And what we were able to do was use a waste from the cooking industry, and then we perfected that to use a waste from the sugar industry to make board which was comparable in terms of its properties with MDF, and we made furniture for them. And we were able to take that to the sort of demonstration stage and be able to make a sort of renewable and recyclable MDF, which was a new product to the market. And we did that starting with Innovation Hub financing to begin with. We've also sort of continued our story in terms of waste, and this is, many of you may know Pankaj Pancholi from Just Egg, and they're another Leicester-based company. And again, they produce, or they boil around about a ton of material a day, and what they find was that they were getting obviously a large amount of eggshell, and it was costing him a significant amount to throw this material away. And here's a picture of me with Pankaj in our fetching hairnets, and this sort of shows that what we were trying to do was develop for him a new plastic that he could use for his packaging of his hard-boiled eggs. And what we were able to do was develop a plant with him that turned his waste material into a resource. So you can see a picture here in the bottom left-hand corner of Pankaj pouring what is purified eggshell, and we were able to make that into a plastic which had the properties that it was significantly harder than normal plastic. And we could take normal high-density polyethylene and replace about 40% of that. So we were taking material that cost about £1,000 a ton, and we were able to replace about 40% of that with a waste material. So Pankaj built his own processing plant, which opened a few years ago. So what I've hopefully shown in this very brief presentation is that we can use techniques like textual analysis. We've got a wide suite of analytical facilities at the university that we can use to understand materials, be they food materials or other sources, and develop new sorts of materials and help you to understand how to optimize processes. And that can be everything from the plastics that go into your packaging through to the energy that you use for a process, through to just optimizing the mass of material that goes into a product. We've also can help in terms of understanding cooking processes by analyzing the texture of the materials during the cooking process. And as I say, we've also got expertise in things like granularization, understanding food authenticity. So we've worked with a number of companies looking for fake or analyzing fake products which have come to market, one of my colleagues also looked at ripening mangoes to find the ideal way of ripening fruit. And we've also got expertise, as I say, in terms of plastics, sustainability, and green energy. So hopefully that's given you an idea of some of the projects that we've done in the past and ways that we've worked with Leicester businesses. Thank you.
Thank you, Andy. Very, very interesting. And from waste to waste, I give voice to Simon. Thank you, Simon,
Hello.
for being with us. I know that you are quite far away at the moment.
I'm in Italy, yes. Yeah, where you're from actually, Carmine, isn't it?
Yes, indeed. Tell us a little bit about Pyrogenesys.
I've got some slides. Let me just make sure I can share my window. Okay, so can you see this all right?
Yes. Thank you.
Okay, brilliant. So first of all, just for your guests, Carmine, they might not be aware, but Pyrogenesys and University of Leicester are project partners. We've worked on several different projects now, and so there's always occasions where we're looking for opportunities to collaborate. And definitely, Professor Andy, I'd be very interested in speaking with you about some of the stuff you were talking about, because we're at the stage that we have developed technology that if you do have waste and you want to do something sustainable with it, then that's where our technology comes in. And we've developed a carbon removal technology, and there's a debate that's starting to happen now about the difference between carbon offsetting and carbon removal. You can't actually achieve net zero without removing carbon from the environment, is my understanding. By all means, feel free to challenge that. So this is really just giving you a bit of an input into the journey from the ideas that we've come up, how we've developed them, and the outcomes that we're going to hope to achieve with this very powerful new technology, which I'm a co-inventor of, called Pyrochemy. I'm also the co-founder and CEO of Pyrogenesys. So let me hope. This is kind of like a process model of what the Pyrochemy technology is. It's a containerized technology specifically developed for factory installations. But in our case, our primary market is actually for rural communities that are off grid, that produce agricultural waste because they're primary producers, but don't have access to electricity or process heat for that matter. And so this waste biomass is typically from the non-useful part of their crop, which they don't like to leave on the fields. But in a factory manufacturing, a food manufacturing setting, this would be, of course, it could be packaging, or it could be peels, or it's just the stuff that you're not going to convert into your food products. So as long as it's a combustible biomass, typically, and it's food grade, then this carbon removal model should work for you. And so what we do is that we feed that into our system, and it comes in ideally dry. We want it to have a fairly good energy content. And this is a pyrolysis-based system that works by heating that material in the absence of oxygen so that it doesn't burn. We want to control when it burns, which would be at this end. Of course, when you do add oxygen, then you get a flame. And so we can use that, therefore, to generate heat and electricity. From the surplus heat, we can also generate cooling using absorption chilling. Now, we always would produce a biochar, and this is where it's very interesting, because the biochar is where we get carbon removal when we sequester it back into horticultural or agricultural applications. And so effectively, what the plants have helped us do in this process is that they've removed gaseous carbon in the form of CO2, stored it in their plant material. If you left that in as a plant material, it would rot and turn either into carbon dioxide, which isn't that bad in comparison to methane, which is 25 times worse, or even worse, nitrous oxides, which are 300 times worse. So we fix that carbon into this solid, stable biochar, which can remain without returning into the environment when you put it into the soil for up to 1,000 years. We can also turn that into, or use it as a smokeless fuel. But what's really interesting as well is that there's other products that we can produce. One is bio-oil, and one of our projects with one of our partners has helped us to develop a renewable kerosene And we're now waiting to hear whether we get some follow-on funding to develop that into Jet A1, a renewable jet fuel, which the aviation industry is desperate to decarbonize. So, so if you've got a waste, and we can either turn it into a carbon removal process via this route, or renewable sustainable aviation fuel via this route, or the fact that you use, so like for instance, with the boiling egg scenario, you need a lot of heat and you don't want to use fossil gas, then you can see how your waste can be very nicely converted into other useful things. Okay, and then this gives you just a bit of an overview of the carbon cycle that involves pyrolysis that I was telling you with the plants. And the pyrolysis converts 50% typically of the carbon into a biochar. Hence, when you sequester it, that's why you remove carbon from the environment. And then the rest, as I say, we're typically converting into energy, and so only 50% returns back to the environment as CO2. So you do return carbon. Here is an application where we're using the biochar as a growth media. So we're running trials. You can see this one over here is darker than this one, and so we're comparing different blends and the good thing about biochar as a growth media, because these are kind of like seedlings, this is a West African crop called yam, and because of course biochar has gone through a heated process, so it's a sterile material. Which just happens to have really good properties due to its porosity, so very good at retaining nutrients and retaining water or moisture. So we're finding we're getting some really good results. So these are trials that are ongoing at the moment with another project partner that we're working with. So it shows you we've got real applications that hopefully will be coming to market anytime within the next 6 to 9 months. Here's some stuff that we put into the public domain. This was just really to educate people about the difference between carbon offsetting and carbon removal. So if you go onto our website, you'll see that there's this social media post that was there on Facebook and LinkedIn and Instagram, I think. But typically with carbon offsetting, you've got a ton of CO2 that's normally being emitted, and somebody has avoided emitting it elsewhere, so they get a carbon credit and they sell that carbon credit because they didn't emit it. You still have, so there's still a ton of carbon CO2 that gets emitted into the environment. However, as you can see over here, with carbon removal, that ton of CO2 has physically been removed from the environment, so you get zero, and that's how we go towards net zero. Okay. So there's a lot more information on our website about that. This is a YouTube video that we've made that explains all about the difference between carbon offsetting and carbon removal. As I said, it's for education purposes. So here's the YouTube link. Carmine, I suppose you could share that with the group later if you want, so you can find out more about it. And yeah, that's really pretty much where we're at. We're looking to work with different companies, because it's a containerized unit, it can process about 1.5 tons of waste a day. So if you've got a factory and, you have an issue with what to do with that waste and want to do something more interesting, then by all means, you can get in touch with us via our website, email, and we've also got our LinkedIn page here, but we're also on Facebook as well and Instagram. Okay, sorry I didn't include those links.
Oh, excellent. I would invite back Andy, and I invite the audience to write any questions you have for Simon and Andy into the chat. In the meantime, I have a few questions for both of you, actually. The first one is...
Can I start on Simon, actually? Can I start on Simon?
Yes, please.
So Simon, in terms of the carbon that you're producing, I think it's a very interesting process, and there's so we're working with a company who's doing a very similar process to you, but doing it with waste. So what they're doing is removing the carbon from things like printed circuit boards, and that then leaves the residue has got a very high metal content, and so we've got a project which is extracting the metal. So I think that's fascinating. So what do you know what form the carbon is in that you've got? Is it sort of graphite or a glassy carbon?
Right. So with you'll produce different characteristics of biochar depending on what you start with. We predominantly focus on, agri-processor or food manufacturing or agricultural waste, because that is suitable for going back into the food chain as long as we pyrolyze it under the right conditions to make sure it has no polyaromatic hydrocarbons and it's compliant with the European biochar certificate. Because if it's going to go into a food production system, you have to avoid contamination that's going to cause, sickness or, it's toxic. So that's why we stick with like a food grade material to go in, so that we can, as long as our pyrolysis conditions are fine, we'll get a food grade biochar coming out, and that biochar will comply with the European biochar certificate. So if you want to know the kind of, you've got different types of carbon, you've got the organic and inorganic carbon, and the organic carbon is the one that is stable and doesn't return to the environment. The other carbon containing molecules are typically in the forms of sugars or acids, which microorganisms can still convert back into carbon dioxide or methane or other things.
Yeah, because the interesting thing there is that what's always very interesting with recycling is when you can upcycle material. So it's looking at the value point for the product that you've got, and obviously as a growth medium that's an interesting application. But a bigger application would be in terms of looking at your material as an active material,
activated carbon.
And so what's interesting is that we've got a big project at the moment looking at land remediation from mining applications. And so if it was a growth medium plus an absorber for metals, for example, then that would have a much higher value point. And so it might be useful to get hold of some of this material and just see what its properties are in terms of its ability to absorb. And then obviously, in terms of the way in which you could then construct things like tailings dams, whether you could then put this as a sort of renewable material, or we're looking at we're talking with a number of companies. So we found, for example, eggshell is a very good absorber of heavy metals, and it's whether you can use, for example, there's a huge need for absorbance within the mining industry, even in legacy mining in the UK. So from old acid mine drainage that you've got from coal mines, there's a need for absorbance in those sorts of areas. So it might be that some of your biochars have actually got a higher value in terms of using them for those kinds of applications.
Definitely, Andy, and that's why we're very interested in working with people who do produce waste, because some wastes are going to, there's a project that we're involved in at the moment with about 3 universities that are looking at activating the biochar, because biochar is just like it's about 5 meters squared per gram. To become activated carbon, it needs to be 500 meters squared per gram. Yeah. So some materials are easier to activate or turn from biochar into activated carbon than others. And then some materials have, well, all of them will have a different surface chemistry. So you're now talking about the chemical interactions, so binding strengths. So some will be better disposed because of the chemistry, the surface chemistry of that material will definitely grab onto certain materials that you want to extract from the environment. So yeah, you might be producing a waste. So like one in particular I know about was like rose cuttings are really good for making activated carbon when you pyrolyze them and then upgrade that biochar. So yeah, in different applications, you'll find that you might have a material, once it's pyrolyzed and then activated, becomes ideal for a certain type of contaminant removal. So we'd love to do all those kind of trials. So yeah, by all means, get in touch if you've got a waste that you want to see how well it works on all sorts. And then yeah, come to you. So we could produce the biochar, activate it, give it to you, and then you'll see what it's best used for removing.
Useful conversation. Thanks.
Thank you. Simon, I have a question for you too, indeed, because we said you are in Italy, you are with one of your industrial partners, indeed. You started from an idea, and then you are doing any possible effort to make it happen. And part of this effort, I see a lot of value into collaboration. How is it working for you, and how wide is your network of project partners?
Okay, yes, collaboration is essential, and really, it's Carmine is a lot to blame for this, because it was a conversation that we just bumped into at the space park, wasn't it, Carmine?
Yeah.
So, first of all, I would always say, if if you see somebody you think, oh, they look interesting, follow it up with just saying, introducing yourself, because that's how we got speaking. And then Carmine explained what he was doing, and I found, oh, he's doing stuff that we really need, which was on the geospatial mapping aspect of, like, so we need to know where waste is produced in an agricultural setting. University of Leicester happened to have a great geospatial department, which Professor Kevin Tanzis, who we ended up working with, thanks to that introduction. And so first of all, it's identifying capabilities and skill sets that we didn't have but that we needed, and it didn't matter that we didn't have them, because we, I think it was University of Leicester even that introduced us to say, oh, have you considered this application? We can apply for some grant funding. The grant funding will provide the resources for us to work together. And then, by working together, it's ended up that University of Leicester has helped us to develop a tool that, we're still developing it. And then, that is an essential tool for helping us with our business modeling, because if we're looking at an off-grid community in sub-Saharan Africa, what we need to know is, do they generate enough waste? So that tool, again, it might be like what you're working on, Andy. You do some analysis to see, what that waste, the potential of that waste is going to be when you pyrolyze it and then activate it. So our partnerships, as a result of getting onto Innovate UK grant funding, which is very competitive, and thanks very much to Innovate UK, because we had 5 projects so far from them. And that helped us to develop international consortia. So we not only work with UK universities, several, we work with organizations, in other countries as well, Italy being one, Sub-Saharan Africa, and I think we worked across Ethiopia, Nigeria, Sierra Leone, and Liberia, and with universities in Africa as well. And so not-for-profit organizations, NGOs who are on the ground, businesses who actually have business operations on the ground. We've worked with a lot of people. I've kind of like relocated to Nigeria now to lead the next stage of our business, but I've still got a team here in the UK. We have incorporated a company in Nigeria. So although we're a small company, we're I think 12 people now, through grant funding and collaborations, we grew from 3 to 12. And, we've now got a company incorporated in Nigeria, and we're also originally from the UK. With COP26 coming up, the British government is keen to promote UK businesses to a lot of countries who don't have the kind of capabilities that we have access to in the UK as a UK company, and working in partnership with UK universities. So Foreign and Commonwealth Development Office are pushing a lot of opportunities in front of us and putting us in front of people as well. And the Department for International Trade likewise. So there's a real good synergy at the moment going on between academia, the British government, these funding bodies, and other people who realize that working with UK businesses is really a good idea, because that helps them access research and development capabilities and resources that they wouldn't otherwise have access to. So collaboration is key, as UK is open for business. And a lot of the world likes how we do business and how we work.
Thank you, Simon. I have a similar question, but in reverse for Andy, because Andy, you work with several businesses, and I would like to understand what are the benefits for industry, academia collaborations, and where are the resources available?
We've had a huge amount of funding from different sources, a lot from the EU, Innovate UK, KTP. I don't think there's a funding source that we haven't used. We have worked with literally hundreds of companies. We had a European consortium of 33 industrial partners. I think it was 13 million euros for that one project. So we can create these very large consortia. It's, from our point of view, it's really trying to understand what the businesses need, and it's a very sort of pragmatic approach to waste. But it's always looking at all sources of materials. So just looking at materials as a value stream, and as Simon's just said, you know, you can, from a pyrolysis process, you've got to look at pretty much every single stream, solid, liquid and gas, and say there's got to be a value in there somewhere. And you know, it was very revolutionary working with British Sugar. We did a nice project on the board project with British Sugar. British Sugar even makes money out of the stones that come out of the field that it washes the sugar beet with. So it's got an aggregate business. So there isn't a single stream, solid, liquid or gas, that comes out of that process that they don't make money out of. So I think it's having that holistic approach with companies that sort of say, you know, why are you throwing that away? You could use this or here, or, you know, by just, you know, doing this in a different way, you can turn a waste into a profit stream.
Thank you.